Welcome surfers, it is Joele and this is Rustlers. In today's video we write our first molecule, CLI ToDo management program, and in this little program we use more or less all the concepts we learned in the previous atoms. Okay. To create a to-do management program, one of the first things to do is create a new type that represents a task as a tuple. The first part of the tuple is a boolean that represents if the task is done or not, and the second part is a text, a simple text. So our new type, task, is equal to a tuple with a boolean and a string. Perfect. We need also a series of functions useful to execute commands or to do specific things in this application. So the first one is the function to load tasks. This function loads all tasks from a specific file and return a vector of task or an input-output error. So return an input-output result with inside a vector of task. Okay. We write this function later. We need also a file name because all tasks are saved in the same file. So we can create a const file name. This const is a string slice and is equal to ToDo.txt. Perfect. This is the name of the file used to store all the tasks. We need another function. In this case, the function needs to save all tasks into the file, and this specific function must overwrite the original file. We write the signature, save tasks. This function needs a list of tasks. This is an immutable list, so we can use a slice of tasks. Perfect. And we return also in this case an input-output result with an empty tuple because we don't need a real result. We need to know only if the input-output operation is okay or have some kind of errors. And now we can create the signature of commands. The first command is list. This command prints all tasks to the console. And also in this case I need a simple result as a return type. Perfect. Okay. Next command. The next command is add. Command add. And also in this case I need an input-output result. But to add a new task I need also a parameter. In this case is the new task is string slice also in this case. words. String. Okay. It's an array of string slice because we can add multiple things. Perfect. Another command is the done command. So function command done with the same result type. Result. And to mark as done a task, I need to identify the task. So identify it with an id string, a string slice also in this case. Perfect. There are other commands. Yes, the delete command. Delete. Same result. And also in this case I need the id string parameter to identify the task to delete. Okay. We can add a couple of other utility to this program. For example, we can create a command to delete all the tasks. So the command can be named clear. Okay. And we can create an help that print a text that describe all the commands. So function print help. This function do not have any return type. I think that we have enough command for a basic ToDo application. So we can start with these helpers to understand what is all the functionality that I have in this app. So print line, usage. Okay, little bit of space, list. Add. Done. Delete. The delete command. Okay, we also specify that all these commands need an ID. The clear command and the help. Okay, these are the full list of commands. In add commands we need a text. In done and delete commands we need an ID as a second parameter. And now we can write a very short description. So show all tasks, add a new task, mark a task as done, delete a task. Delete all tasks and show this help. Okay, this is our super simple help for the ToDo application. Now, one of the most important operation is the operation to load all the tasks from a file. If the file do not exist, I need to return an empty list of tasks. So if not path new file name exists. So if this path do not exist, I simply return OK, the result with an empty vector, an empty list. Perfect. If the file exists, I need to read the whole file content and put this content into a string. So let content equal to read to string the file name. Okay. This function return an input-output result, so I can use the question mark to return the error, eventually an error happen. Okay, now I need an empty vector collection. Okay, back is wrong. And also this is unequal. Perfect. And now I can iterate through each line of the file. So for line in content lines, I expect a specific format for each line. The format is 0 text or 1 other text. This integer is the status of the task. 0 not done, 1 done. Okay, so I need to split the line. Split and I need to split only at the first division symbol. So 2 with this symbol. Okay. Perfect. And with these two parts, I put it in two different variables. Parts next is the first part, and again parts next is the second part. Okay. Now I can match these two different parts to create a valid task of the task type. So let's parsed equal to match status and text. Parsed. Okay. If I have some 0 and some generic text t, our parsed task is false and t to string. Okay. If I have some 1 okay, and again some t, I return a task done, true, and again t to string. Okay. It's useful to skip each other case, so each malformed lines that do not follow this standard. Continue. Perfect. And when I have a full task object, I can push it in our list. Our list is tasks. Yes, it's tasks. Okay, parsed. Perfect. When this tasks list is complete, I simply return it inside an OK result. And I don't use any symbol after the result because I need to return this value. Perfect. The first utility function is ready. Now the second one is the function to save all tasks into a specific file. I create a new string and for each task as reference in tasks let flag equal to if done equal to 1, else equal to 0. Some spacing here and here. Okay. Semicolon. And now I can push all these things inside out. Push str format we use our standard and a new line at the end. We format in this shape our flag and our text. Okay. Now I simply write all of these in our file. So file system write file name out. Okay. and also in this case I need to return the same result, okay, on error of this input output operation. So my return type of this function is a result, is the same of the write function. Okay, now we can start with all commands. To list all tasks, we create list of tasks with the load tasks function. Okay. If no task exists, we simply print a message. So if tasks is empty, we print line no tasks yet, and return okay result, an empty result also in this case. Perfect. If I have some tasks, I can print each task with indexed and status. The index is simple, the position inside the list. So for I in from 0 to tasks length let done ref text equals to tasks at position I, tasks, okay, and we can create our box char equal if the task is done, we use an X, else we use an empty space. Okay. Now I can print all of this. So print line, our box char is here inside a box, a formatted text, okay, and the text, this is the status, this is the text of our task. Box char I+1 and text. Okay. At the end, if there aren't error, I simply return an okay result with an empty tuple inside. Okay. Some spacing here, and it's done. Perfect. The next command is add. If we don't have any word, we simply print an error and with a print and return an empty result. So if words is empty, okay, if word is empty, a print I print the command to add a new task and return an okay empty result. Perfect. If I have something inside words, I need to reconstruct the task text by joining all words. So let mutable text equal to string new, and for enY in words iter enumerate, okay, and also iter is a function call. If I is greater than 0, text push an empty char. Okay. Okay. And I need to push also the word, so text push str w. Okay. Now I load all tasks and append the new one at the end, and then I can save back the file. So this is the list of all tasks of all previous saved tasks. I can push the new task and I can save this. Perfect. Now I can also advise the user that I have added a new task with success, and okay, I return an empty okay result. Okay, result is this. Perfect. This looks pretty good, and we can pass to the next one, the function to mark as done one task identified by its ID. First of all, we need the ID, so we need to parse the ID input to a number of u sides, because this number is the sides, the position inside a vector. I can match id str parse, and if the parsing is okay, I simply return this number. If I have an error, I need to print a print line. id must be a positive number. Okay, and return. Okay. Perfect. If id is equal to 0, I need to print another error because id is start at 1. So if id is equal to 0, I print another error. Id is start at 1 and return another empty OK status. Print line. Okay. Now I can create a list of tasks, loading all tasks in my file with our function equal to load tasks. Okay. And now I check ID bounds to understand if I have a task with this specific ID. So if our ID is bigger than tasks len, I print another error, print line. No task with ID something. And return OK again. Yes. OK. Now I have complete all the checks, so I can set the tasks flag to true. Tasks I.0 equal to true. And I can save the updated list of tasks. I can print something to the user. A marked number something as done. Something is our ID. And at the end I simply return our empty OK result. Perfect. Now, more or less is the same thing to do for the delete command. So again, I can pass our ID input in an usize integer, unsigned integer, match dstr parse. Okay. And again, okay, and if the parsing can be completed or error. If the parsing cannot be completed, this error I print to the error std stream id must be a positive number, and I return our OK result. Perfect. Now, if id is again equal to 0, I print it is must start at 1. The message is the same, make this start at 1. And then return okay, empty result. Again, I need to load all tasks saved in my file. Load tasks. And check again if our ID is valid, greater than tasks len. No tasks with ID something, ID return okay. And I need to keep all tasks except the one to remove. So let mutable keep a new vec and for I in 0 tasks len if I is not equal to id minus 1, I keep it. I clone. Now I save all the keeped tasks. Save tasks kept, and I can print a message to the user: deleted number something. Okay, the empty result. Perfect. The clear command is much easier, so I need simply to save an empty slice of tasks and print something to the user. Okay. Sorry. Perfect. I have all my help, and now I need to use this tool with a command line. So first of all, I collect all command line arguments into a vector. Call it args, a vector of string. And args collect. We must add all these library to the start of our source file. We used environment to reading command line arguments, and we use interface to reading and writing files. We use input output to import our input output result for error handling, and we used also a path, okay, for file system path operations. Okay, return back to our main. Now I need at least one command. If there aren't commands, I simply can print or help. So if args len less than 2, print help, and return our empty okay result. Else, if I have enough arguments, I match args1 as str, and if our str is a list, I invoke the command list. If is add, I invoke the command add, in this case with args. Args 2 okay. If I have done, I check if args length is less than 3, and in this case I print the right usage of the delete command. So error print line usage del id, and okay. Else I invoke the command delete with args2. Okay. Perfect. Now if I have the done command, maybe okay, another parenthesis. If I have the clear command, I prefer to add a space here. Okay. With the clear command, I simply invoke command clear. And if I have help, I print our help, and return our standard empty. Okay, result. Okay. I can add some aliases to this command, for example, -h or help. Okay. If I have unknown command, other command, I print an error, print line, unknown command something, the name of the unknown command, other, and I print again or help, and I return our empty standard result. Okay. Now I can close our match, and I can also close or else. This is the right closure, I think. Yes. Okay. So let result, no, is not this, but is this the right closure? Perfect. Okay. If any command return an error, I simply print this error. Okay, result, error print line, error. Okay. I think that we have a full code list. Let's run and try to understand errors and to correct it. So cargo run. Okay. I don't have specific errors. Let's try cargo run list. Okay. Cargo run add test to do one and cargo run list again. No, there are something wrong. Yes, first thing, I need to save this file. Okay. Line 40. Okay, this is an error. Okay. We have a lot of small errors. Line 9, line 45, in line 9 I simply forgot this. In line 45, flag text. Okay. In line 121. Okay. In this case, the problem is that, oh, okay, I missed to return something, to return n, the number of the parsed ID. 203. Okay, this is inside here. 180. Print line, perfect. '83. Tasks. Okay. 104. No method named len found for a number result. 104. 104. Okay. This is the done command. Let's see. Okay, I forgot here to unpack the result. And $110. Okay, I think the source of the error is the same. Perfect. Save this file. And check this couple of other errors. Print line again, line 1, 2, 3. Print line. And push string. Okay, this is line 45. Line 45 in the save task. So, okay, to push stl, I need to use the reference of the string. Okay, let's play with our app. Run add test to do 1. Perfetto. Test to do 2. Perfetto. Test to do 3, 4 and 5. And now list. We have 5 tasks. Now we can done the task 2. Deleted, why deleted? Check the done command. Okay, done command. different here. Okay, this is the delete. Okay, but if this is the delete, I don't have done. No, I think that I don't have done. So let's add the done command, and if argslen less than 3, okay, I can print an error and print line usage done id. Okay, else I run command done with args2 cmd done. Okay, perfect. Now we can add something. No, is not needed. Try again. Run done number 2 cargo run done number 2. Okay, and as you can see, the test to do number 2 now is marked as done. I can test cargo run delete the number 3. Okay, perfect. Cargo run list. Okay, the last one to test is clear. Okay, now I don't have any tasks. Add test to do 1. Perfect. And now I can open the to-do txt, and as you can see, inside the txt file I have our standard format. So the first one is a number that represents a boolean, done or not done, separator character, and our text of the to-do. Perfect. This is our molecule. This molecule can be optimized, can be improved, but the important thing is that in this code we understand how to use the majority of things that we learned in the previous atoms. So for this video it's all. See you in the next atom, the part 2 of Rustlers, and don't forget to subscribe to this channel and to keep your thinking cap on.